Today we will see load duration curves and various factors governing the load duration curves. Okay, what is meant by load duration curve? Okay, as the load required by consumer, I will select 1 minute. I will select laser. Okay, the load required by consumer does not remain constant with respect to time, and it fluctuates according to his requirement. Okay, if you consider a case in your own home, okay, for some time you switch on the TV, after some time you switch off TV and switch on some other load in other room, for example fan or light or laptop. Okay, means what, they are not continuously running. The switching on off of various loads in load is happening. Okay, such cases are there, for example in malls, offices, institutes. Okay, everywhere the loads are switching on and off as per the requirement. Okay, so the load fluctuates according to the requirement of consumer. Okay, a curve showing the load demand variations of consumers with respect to time is nothing but what? A load curve. Okay, variation of load with respect to time. If the time is in hours, the load curve is known as a daily load curve. Okay, means what? A daily load curve will give you information of variation in load in a day. Okay, for that you have to select x-axis or time axis in hours. If the time is in days, the load curve is known as monthly load curve. Okay, it will give the information about a month. And if the time is in months, okay, x-axis or time axis is in months, the load curve is known as yearly or annual load curve. Okay, this type is what? Annual load curve is useful in predicting annual requirements of energy and capacity of power plant required. Okay, from annual load curve, what information we will get? We can predict the annual requirements of energy. Okay, what will be the requirement of energy in future? Okay, we can anticipate it from current load curve. Also, we can calculate the capacity of power plant required in future, okay, to meet the future loads, future increasing in load. Okay, this is a particular load duration curve. Okay, where you can see that x-axis is a time in hours and y-axis is load in kilowatt or megawatt. Okay, means what, it is a daily load curve because the time axis information is in terms of what, hours. Okay, so it is a daily load curve. Okay, here you can observe that the increase in load, okay, and the maximum demand at the morning is at 9 a.m. okay, because the consumers are rushing to the offices. So for example, if you consider the example of Mumbai, okay, locals which running on electricity will have a demand. Okay, electricity demand. Okay, when they reach office, okay, offices will open, ACs will turn on, okay, lights will turn on, fans will turn on. Okay, so we will require the so you will observe the increasing the load. Okay, and it is the maximum at 9 a.m. okay, when you settle in the office, okay, okay, when we reach in the office, what will happen? The locomotives in intensity, running intensity will decrease. Okay, means what, the electricity requirement will decrease. Okay, and only the loads in the offices, okay, shops will increase. Okay, so we will come to a average load. Okay, low demand is here. Okay, again when office time is over and you are rushing to home, okay, what will happen? Locomotives or locals will again run. Okay, their intensity will increase, so a peak load will happen at 6 p.m. and at the same time lights on the street will start to on, okay, and lights in the homes, shops, malls will turn on, okay. So you can observe that the peak load here is greater than what is there in morning, okay. Peak load at the evening is greater than that of the morning, okay. And again when you reach home, okay, what will happen, the intensity of running locomotives will decrease, so the load requirement will decrease. And as time approaches 9 a.m. and above, okay, means what, when night appears, what will happen, most of the malls, offices, okay, shops will switch off, okay. So therefore the demand will decrease, okay, it will be lowest at around 12 p.m. Okay. Next are the factors governing planning a power plant. Okay, which are the factors when planning a power plant? The two basic parameters to be decided. Okay, which are those parameters? First is the total power output to be installed. Okay, means what? What will be the power capacity of a particular power plant? Okay, it's it is expressed in kW installed. Okay, kW is the unit of the power. And second parameter is size of generating units. Okay, what will be the size of generating unit? Okay, you have to decide the size of generating unit by considering what will be the future requirement of power, okay, for future increase in the demand. Okay, you have to consider those things also. Okay, we will see that in detail. The first factor, okay, the total installed capacity, okay, required can be determined from, okay, for this first factor, total power output to be installed, okay, is again dependent on three things. First is the first demand estimated. Okay, when you planning a plant, okay, you have to anticipate what will be the increase in demand in future. Anticipation means what, to predict, okay, to predict what will be the increase in demand. Okay, for estimating the expected maximum load, the most useful tool is the construction of a hypothetical load curve. Okay, hypothetical load curve means what? You have a current load curve, and from that you are predicting what will be the increase in load demand in future, and you are drawing a new load curve which incorporates future load demand as well. Okay, that is nothing but a hypothetical, which hypothetical means what, which depends on hypothesis, okay, prediction. Okay, second is the growth of demand anticipated. Okay, the numbering is something somewhat wrong. Okay, second point is the growth of demand anticipated, means what, you have to predict, you have to anticipate what will the future growth in demand. Okay, and third is the reserve capacity required. Okay, means what, suppose the load demand will is 1 megawatt, then your plant must have a capacity greater than 1 megawatt. For example, if the plant capacity is 1.2 megawatt, then you can say that the zero point 0.2 megawatt is the reserve capacity. Okay, okay, the reserve or capacity of the plant is greater than the maximum demand or the current load. Okay, you have to maintain that. Okay, means by considering the increase in the load, growth in the load in future. The next is the size of generating units. Okay, the size of generating units will depend on, okay, the second point, okay, here the size of generating unit, again it depends on these six parameters. Okay, these six things. First is the variation of load during 24 hours. Okay, uh, when minimum demand is there, when average load demand is there, when peak will happen. Okay, you have to consider all those things. Okay, and according to that, the size of generating units will be selected. Okay, and also you have to see what is the load curve in summer, winter, on weekdays, holidays. Okay, all these things you have to consider. The second is the total capacity of units connected to electric grid. Okay, if, for example, if you consider the example in Maharashtra, there are the main units, power generating units are in Chandrapur, which are coal-based power plant, or in Parri. Okay, and some of the generating units are at hydropower plants like Koina, okay, or Kane, Dhom, etc. Okay, you have to take into account which unit will be run to provide a base load, and which units will be turned on to provide a peak load. Okay, peak load time. Okay, you have to check all these things. Okay, means what? Total capacity of units connected to the electric grid will affect the size of generating units. Okay, next is the minimum startup and shutdown periods of the units. Okay, means what? How much time a particular power plant unit will require to warm up. Okay, and to connect a particular grid. Okay, warming of time is there. Also, whether your power plant unit is continuously running, or it will be turned on only peak demand is there. Okay, you have to consider all these things. Okay, considering that, you have to schedule shutdown periods. Okay, maybe for a maintenance. Okay, fourth point is that the maintenance program planned. Okay, for example, in India or in most of the nations, okay, the summer is the time of the vacation. Okay, means what? Most of the offices, most of the industries are turned off in that time. Okay, we can consider they are running at low load. Okay, low demand is there. Okay, in that period you can schedule maintenance of a power plant unit. Okay, you have to consider that thing. Next is the plant efficiency versus size of unit. Okay, you know that the a particular generator will give maximum efficiency when it is running on a full load. Okay, but considering the reserve capacity, okay, means what? The growth of load in future, we are uh, we are selecting a unit which has a capacity greater than a current load demand. Okay, but uh, capacity of load which is a much more greater will give a less efficiency. Means what? Overrated units will not be there. Okay, similarly, underrated unit must not be there, because if a unit is providing a power equal to zero point 0.9 megawatt, and and the load demand is 1 megawatt, then what will happen? The losses will be there. Okay, heating losses will be there. Okay, it's what? Underrated is not will not be there, or overrated will not be there. Okay, you have to select a exact size of a unit. Okay, next point is the price and space demand per kilowatt versus size of unit. Okay, what is the price of a particular unit? What is the space required to generate electricity per kilowatt? Those things also must be considered. Okay, as the size will increase, the price and space also will increase. All things must be take into account, because there may be a size restriction depending on the size of the power plant. Okay, these are the various load curves in metropolitan area. Metropolitan area means what? In Pune or in Mumbai, Thane. Okay, those areas. Okay, this is the residential load curve. Okay, you can see that this curve, okay, dark curve is in the winter. Okay, obviously there may be a peak load. Okay, peak load at the morning when people are running to offices. Okay, and they are traveling through locomotives. Also, the increasing load at the evening because they are rushing to home. Also, the street lights, malls will be on. Okay, that is why the peak load is there. And in summer, okay, it is the vacation period, okay, maybe their industries, colleges, institutes, these loads are turned off, okay. Means what? The uh, uh, means what? The power plant is providing a base load, okay, you can say that it is a base load or minimum load. But in vacation also we went to malls, shops, okay, and the street lights will be turned on, okay. So this increase will be there, okay, always throughout the year, okay. The second graph is about industrial load curve for one shift, okay. uh, from if we consider the shift from 8 a.m. to uh, 8 a.m. to 5 p.m. Okay, some such shifts are there. Okay, uh, the increase in load again because of the locomotives running. Okay, uh, they are sending people to the offices. Okay, and when they reach the industry is running. Okay, means what? The load demand from industry is increased, and in between lunchtime. Okay, it is the lunchtime. Okay, the industries will be turned off. Okay, and again when lunchtime is over, it is again turned on, various processes will turn on, and the load demand will increase. And when the industry uh, is uh, is going to be off, okay, when the people are going to home, okay, because their period is over, then shift is over, okay, so they are rushing to home, and so the decrease in load is there, okay. It is a particular industrial load. Next is the commercial loads of shops, offices, and hospitals. Okay, the office loads, sorry, commercial loads means what? It consists of shops, malls, hospitals. Okay, they are running throughout the day. Hospitals, okay, throughout the day, and at the night, the customers or patients coming to the hospital or shops, okay, they are decreasing. Okay, so the load is decreased. Next is the urban traction load curve. Okay, it is the load curve of locomotive. You can see that is locomotive. At the morning at 9 a.m. it is the highest. Again at the evening around 6 p.m. Okay, for 5 to 6 p.m. it is the highest. Okay, street light load. Okay, it will turn on from evening 7 p.m. to morning 6 p.m. Okay, and throughout the day they are switched off. Okay, means what? Zero load demand is there. Next is the water pumping load. Okay, MSCB or any state running utility gives the schedule of when the pumps at the particular farm, okay, will be turned on or off. Okay, according to that a particular load demand will happen. Okay, they are, in that case they have shown the load demand at 6 p.m. maybe in case of farmland, okay, the demand may be in the night as per the schedule provided by the MSCB. Okay, various factors used in electricity supply industry. Okay, these are the factors. Okay, figure 2, okay, it will be the next. Figure 2 shows the typical hourly load curve in metropolitan area from which maximum demand can be estimated. Several factors used in electricity supply industry are, okay, first we will see the figure 2. Here is the figure 2. I think this is the figure 2. Okay, we have seen already seen that. Okay, that figure shows what? A typical hourly load curve in metropolitan area, okay, of various loads. This is the curve in metropolitan area of residential, industrial, commercial loads, urban traction loads, street lighting, water pumping load. Okay, various loads are there. Several factors used in electricity supply industry are, these are the factors. First is the load factor. Second is the capacity factor or plant factor. Next is the reserve factor. Then demand factor, diversity factor, and plant use factor. These are the factors we have to see its their definition and formulas. Okay. First is the load factor. Load factor it is denoted by the symbol small m is equal to average load over a given time interval divided by peak load during the same time interval. Okay, for example, if you considering a day, okay, you have to calculate the what is the average load in a particular 24-hour duration. Okay, and if there is a peak load happening there, okay, for example at 6 p.m., then what is the peak load demand? Okay, their ratio is nothing but what a load factor. Okay, here the formula is given in also in year. M is equal to kWh average in a year. Okay, the unit must be in kW. Okay, if there is a data given in megawatt, you have to convert it into kilowatt. Okay, or divide with the same units, megawatt by megawatt. Okay, it will be fine. M is equal to kWh average in a year divided by kW max into 8760. Okay, 1 year is equal to 8760 hours. Okay, you have to consider these units. Okay, if you are using kW in numerator and kW in denominator, this quantity must be in hours. Okay, maybe they give 6 months. Okay, you have to divide this by 2. For example, if a plant has a peak load of 1000 megawatt, okay, peak load is of 1000 megawatt, and the average annual load is 350 megawatt, then load factor will be M is equal to 350 by 1000. Okay, average load divided by peak load is equal to again 0.35. Such examples I will give you in assignments. The average load is estimated by dividing area under daily load curve by time period considered. Okay, how you can calculate the average load? Obviously, area under the curve divided by 24, or you can calculate like this. Okay, I will show you. Okay, consider this is the, I will select again pen. For example, consider this is a load. Okay, the area under the curve means what? You have to calculate this area. Okay, the best method is to integrate. Okay, so the average load is equal to area under the load curve divided by 24. You have to integrate to calculate by that method. Next factor is the plant factor. Again I will select laser. Okay, plant factor. A plant factor is also known as a capacity factor. Okay, is given as N is equal to average load divided by rated capacity of plant. Okay, means what? It is the ratio of what is the average load divided by capacity of plant is equal to, obviously average load is expressed in kWh generated in a year. Means what? It is the energy. kWh means what? Energy, and it is divided by kW installed. Okay, means what? Capacity of plant into 24 into 365. Okay, again it is in kWh. Okay, total hours in a year is 8760. So N is equal to kWh generated in a year divided by kW installed. Okay, capacity is given in terms of power, megawatt or kW. Okay, it is when multiplied by 8760, you will get energy. Okay, the symbol of plant factor is small here. If the rated capacity of plant is equal to peak load, then the load factor and capacitor factor will be numerically equal. Okay, what is the definition of load factor? It is divided by peak load during the same time interval, and the plant factor, it is divided by capacity. Okay, I have already shown it, or I have already mentioned that suppose this is the peak demand. Okay, I will select again pen. Okay, suppose this is the your peak demand. Then the capacity of plant is selected greater than the whatever with the peak demand. Okay, this is the capacity of plant. Always capacity of plant is greater than the peak load. And suppose if the capacity of plant is equal to, suppose capacity of plant is equal to peak load or maximum demand. Okay, then what will happen? Load factor will become is equal to plant factor or capacity factor. Okay, because in case of load factor, average load is divided by maximum or peak load, and in case of plant factor, average load is divided by the capacity of plant. And if these two things equal, then what will happen? The load factor and equal to plant factor. Pratiksha Patil, are you there? Pratiksha?
Yes, sir. Yes.
Okay. I said that load factor is equal to capacitor when
When peak load is equal to average.
no peak load is equal to capacity of the factor.
Capacity load.
Okay, denominator the numerator of load factor and capacity factor both are same, but when the denominator becomes equal, then those things will be same. Okay, means what? When peak load is equal to capacity.
Capacity load.
Okay. Next is the reserve factor. Reserve factor denotes what? The difference between a load factor and capacity factor is an indication of reserve capacity. Okay, I just shown you that the capacity of the plant must be greater than peak load demand. Okay, that by how much factor the capacity is greater than the peak load demand. Okay, it is denoted by what? Reserve factor. Okay, the reserve factor is denoted by the symbol small r. Okay, is equal to load factor by plant factor, that is m by n is equal to kW installed by kW maximum. Consider suppose plant factor is greater than the load factor. Okay, when plant factor n is greater than m, okay, what will happen? The R will be low. Okay, R will decrease. Okay, R will decrease, or vice versa. When n is less than m, okay, plant factor is less than load factor, then what will happen? Reserve factor will increase. Okay, means what? Those things are affecting the value of reserve factor. Okay, next is the demand factor. Demand factor is each consumer has a connected load, which is the sum of continuous ratings of all equipment and outlets on the consumer circuit. For example, if you consider your house, then what are the connected load? Okay, maybe lights, refrigerator, AC, fans, okay, iron. Okay, all these are the connected loads. Okay. I will select again laser. The maximum demand is the maximum load which a consumer uses at any time. Okay, we know that what is the maximum demand or peak demand. It is always less than or equal to connected load. Okay, the demand factor, which is denoted by DEM, is equal to actual maximum load divided by total connected load. Means what? A total connected load means what? kW or wattage, addition of wattage of all the connected load in the house. Okay, it when it divides a maximum load, we will get a demand factor. Okay, obviously total connected load are always greater than actual maximum load demand. Okay, so this factor is always less than 1. Demand factor is always less than 1, is equal to kW max by kW connected. Next is the diversity factor. The time distribution of maximum demands for similar types of consumers is measured by term called diversity factor. Time distribution, what is the diversity in the load distribution, okay, over a given time period, okay, that is the diversity factor, okay, it is very important. It is the ratio of sum of maximum demands of individual consumers and the simultaneous maximum demand of the whole group during a particular time, okay. The same definition is expressed in equation, okay. It is diversity factor is shown by div is equal to sum of maximum demands of individual consumer groups, okay. For example, there are the consumer groups like shop is the one type of consumer group, malls are the others, offices are the others, industries are the others, okay. Whatever will be their maximum demands, okay, we have to add them, okay, and it must be divided by actual peak load of the system. Actual peak load of the system means what? If you observe here the maximum demand or peak demand of residential load curve is at around 9 a.m. in morning and 6 p.m. in evening, but the maximum demand of the uh, industrial load is from 8 p.m. to 11, sorry, 8 a.m. to 11 a.m. and from 1 p.m. to around 5 p.m. Okay, this is what the time distribution of maximum demands are different, okay. You can also see here, okay, in case of shops or offices or hospitals, okay, the time duration is different, okay. For in case of urban traction and load curve, okay, only two instances are there, okay, of maximum demand, okay. This is what the maximum demands of various loads will happen at various times, okay. You have to add all these maximum demands, okay, to form numerator of this term, and it must be divided by actual peak load of the system. I mean all the curves, okay, means what the uh, curve of residential load curve, curve of industrial load,